This is section 6.3, graphing linear relations. Okay, so we've been talking about lines and points on a line, and what we're going to talk about today is actually coming up with our own points to graph on a line. When we graph lines, there's actually an infinite number of points. So you could pick any point, and when you graph it, it should be on a line when we're doing linear stuff. So basically what they mean here is, say we've got our graph here, we end up graphing that line, and what they're saying is we're going to put those arrows on each end because it's going in both directions forever, and there's an infinite amount of points that are going to be on that line. So like point there, point there, point there, point there, and all the way across there forever, continuing on with those arrows. But we're not going to draw them all out because that would take, forever to do. So that's why you put those arrows on the ends to represent that it's going in both directions forever and has an infinite number of points. So your solutions of your equation are going to be all of those points that are on the line. So again, you're just going to come up with some of them instead of coming up with all of them because it's impossible to come up with all of them. And then you draw those arrows in so that that shows that there is an infinite number going in both directions. Okay, so next thing here is linear equations. So it's an equation that can be written in the form a, which is just a number in front of your x, plus b, which again is just a number in front of your y, is equal to, and then c is also just a number. With these, your a and your b cannot be 0 at the same time, because if you have that, so like 0 times your x and 0 times your y is equal to, something for your c, that would be 0 times your x and 0 times your y, which would cancel out all of your variables and come up to something like that, which doesn't really make sense. So you can't have anything like that. Anytime we deal with linear equations, it's always going to end up being a straight line. Linear kind of sounds like line, so that's where they kind of get that name from. Okay, so what they're going to ask you for the first set of questions is figuring out if an equation is linear or if it's nonlinear. So nonlinear is just not linear. Okay, so what we want to do is we want to see if it's going to be, if it can be written in this form here. This form is called standard form, so when you've got a number and then your x plus a number and then your y is equal to a number. So a lot of times you can try to get the equation to that form, and if it can fit in this form, then you're good to go. If it can't fit in that form, then it's not going to be linear. So looking at our options here, all of the ones in this first column are linear. So the first one, we've got 4y is equal to x minus 2. So even though that's not written exactly like it's listed here, you could take and subtract x from each side and have it where your x is now on the other side and equaling just a number on your right side there. This one here is written in that form really nicely. So 3x plus 4y is equal to a number there, so that fits that form. You can also have situations where it's just y is equal to a number, and that would come out to be linear. You could also have x is equal to a number, so like say x is equal to 3 or something like that. That would also be linear. Okay. Our nonlinear ones would be examples like these. So if you look at this first one here, we've got 2x plus 4y is equal to 3z. So since we have that z with that 3, that would be a third variable that we don't want, so that would be nonlinear. This next one here, we have an x and a y being multiplied, and we can only add our x's and our y's, so that's why that one would be nonlinear. And then here, since we have a variable squared, so x to the power of 2, that would make that nonlinear. Okay, so you're basically picking out things that would make it weird and not fit this form here. Okay, so example 1, we're supposed to determine whether each equation is a linear equation. If so, identify our a, b, and c when written in standard form. Okay, so what we're doing is we're looking for weird stuff. So we're looking for an extra variable, or we're looking for variables being multiplied, or variables being squared, or divided, or something kind of goofy. So if I look at this first one here, I've got y is equal to 4 plus 3x. So with this one, I don't see any extra variables. I don't see anything being multiplied, so like 2 variables being multiplied, nothing being squared or divided, so this one's okay. Now what I want to do is I want to get this in standard form where both my x and my y are on the same side. So to do that, basically I'm going to keep my y on this side and I'm going to move my x to my other side. So anytime I'm moving from side to side of the equation, I always have to do opposites. So here, to get rid of adding 3x, I'm going to subtract 3x from each side. Because then I could write it out as negative 3x plus y is equal to 4. And now that looks more similar to what our standard form looks like, where our x and our y are added on the same side, equaling a number. So now we know it's going to fit that form there, so this is linear. And then what they want us to do, if it is linear, is they want us to identify our a, our b, and our c. So our a always goes with the x value, so our a in this case is going to be the negative 3. Our b always goes with the y, and since there's nothing listed in front of the y, that's like a 1y, so our b is going to be 1. And then our c is our constant value that's on the other side of the equal by itself, so our c in this case is going to be 4. Okay, next one here, we've got 4xy is equal to 4. So thinking through my nonlinear things, I've got two variables, so that's good, not an extra third one. I've got an x times a y. So if I've got an x times a y, that's similar to my nonlinear side, so this one is going to be nonlinear because of that x times the y. You're not allowed to have that. Okay, this one here for C, x is equal to, or sorry, y is equal to x. Okay, a lot of times people have a hard time on this one, but this one is actually linear because what I can do is I can take both of those and move them to the same side of the equation. So what I could do here is I could subtract x from each side and have negative x plus y is equal to, and then when I do that there, usually I don't like to do that because then it puts nothing over there. But in this case, I want to do that because then it's going to put a 0 over there. And now I'm in that form I want to be. So even though it does look kind of goofy here, this would be a linear one. And then our a value would be in front of the x. So our a would be negative 1. Since it's a negative there, that's like a negative 1x. Our y would be like a 1y. So b would be 1. And then our c would be 0. Okay, so that's kind of a goofy one. Okay. And then our last one here of those, we've got y is equal to 7. Okay, so again, this is kind of a goofy one where they're kind of trying to trick you. So this one is going to be linear. Reason being is I could take and put a 0 with my x, and then plus y is equal to 7. And 0 plus x basically would cancel out, so that's the same as that. Okay, so this would fit that form, even though there is no x there. It does actually fit the form. So then when we write out our a, our b, and our c, our a is just going to be 0 with the x because it's non-existent up here. Okay, so you can put it in that form even if it is just y is equal to 7. It can go in that form. So our y then would be, or our b value with the y would be 1, and then our c value would be 7. This could also work if it was like x is equal to 7. You could add like a 0y. So it would be like x plus 0y is equal to 7. So that could work too, just if you ever get a situation like that. And it would still be linear. Okay, switching gears here. Basically what we're going to do is we're going to graph some equations. So before, when they asked us to graph some equations, they would give us a set of ordered pairs, or they would give us a domain or a range, and they would give us numbers that we would need to plug in. Here we get a little bit of freedom because we can actually pick which numbers we want to plug in. Okay, so usually what I do is I pick numbers that are fairly simple and not like too hard to multiply or add or anything like that. So typically when I pick my values here, I usually do -1, 0, and 1. Okay, because 0 is usually really easy to work with, and then I usually pick a positive and a negative because as you get to higher up maths, it makes a difference sometimes if you've got negative versus positive numbers. So that's usually why I pick those three numbers. Okay, and then I've got my equation is y is equal to -x plus 2, and I'm trying to come up with ordered pairs, x and y, that I can graph there. Okay, so I just plug in my x values that I picked out, and really you could pick anything there. So I've got my negative in front of the x, and then my x value is a negative, so negative 1 plus 2. So here I'm taking negative times negative, which would be a positive 1, plus 2 is 3. So negative 1, 3. Plug in 0, so y is equal to negative times my 0 plus 2. Negative times a 0 is 0, plus 2 is 2. So 0, 2. And then my last one there, y is equal to negative, and then I plug in my 1 plus 2. So negative times the 1 is negative 1, plus 2 is 1. So 1, 1 for my ordered pair. And with these, the minimum amount of points that you can use is 3. If you want to use more than 3 points, you can, but you have to use at least 3 points when you do these out. Okay, so then I just go and graph those. So negative 1, 3, so left 1 and up 3. 0, 2, go over 0, up 2. And then 1, 1, right 1, up 1. And again, when you graph these, they should come out to be straight lines. If it doesn't come out to be a straight line, you either graphed it wrong, or when you plugged in your points, you solved out wrong. So it always should be a straight line. Okay, next one here. So same situation, we get to pick our own points to plug in here. Now, with that last one that we did, we had where it was y equals and then the other stuff. So typically what I do is I try to get these in y equals form so I can just plug in some x's and then solve out and it comes out nicely. You don't have to, but if you don't solve it out right away, it ends up being more work in the long run. So I would highly suggest solving it out for y to start so it's easier to do as you go. Otherwise, you'll end up doing more work if you don't solve out right away. Okay, so what I would do here is I would get this equation to y equals. So I would get rid of the 3x first by subtracting 3x from each side. So then I'd have negative y, don't forget the negative, is equal to negative 3x plus 2. And then to get the y by itself, I've got to get rid of that negative, so I'm going to divide by negative 1 on each side. So then I'd have y is equal to negative 3x divided by negative 1 would be positive 3x, and then 2 divided by negative 1 would be negative 2 or minus 2. Now I can use that equation, since it's in y equals, in my chart here. So y equals 3x minus 2, pick out some x's to plug in, and come out with my ordered pairs that I can go and graph. Okay, so again, I'm going to just pick whatever numbers I want here for my x. I like to pick easy numbers, so negative 1, 0, and 1, because those are nice to work with. So I'm going to plug in here y is equal to 3 times my x value, which is negative 1, minus 2. So 3 times negative 1 would be negative 3, minus 2 is negative 5. So negative 1, negative 5. Then I plug in 0, so 3 times 0, minus 2, so 3 times 0 is 0, minus 2 is negative 2, so 0, negative 2. And then I'm going to plug 1 in for my x for the last one, so y is equal to 3, and then for my x I'm going to plug in a 1, minus 2, 3 times 1 is 3, minus 2 is 1, so 1 for my x, 1 for my y when I solved out. Then again, I just take those points and I plot them. So negative 1, negative 5 would be left 1 and then down 5. 0, negative 2 would be over 0, so I don't move at all, and then down 2. And then 1, 1 would be right 1 and up 1. And then I just take and I shoot a line through those guys. And it should end up being a straight line there. Okay, so if you want to, you can try the ones on page 252. I'm not going to do this out here. So with these, if you plug in for like D, if you use, what do I want to do here for my X, if I go negative 1, 0, and 1, and then I've got my equation like that. For your X and your Y, you should end up with negative 5, so negative 1, negative 5. This one, it would be, no, that's not right. negative 1 times negative 2, this would be negative 3. I should just do them out. So this would be 2 times negative 1 minus 1, so negative 2, so negative 3. This one would be 2 times 0 minus 1, so that would be 0, negative 1. And then 2 times 1 minus 1, 2 minus 1 would be 1, so 1, 1 for that one. So then you would just graph those guys out. For E, when you first start, so you got 3x plus 2y is equal to 4. With one like this, I would solve for y to start, so I would I'd probably subtract 3x from each side, and then I would have 2y is equal to negative 3x plus 4, and then I would take both sides and divide by 2. So y would equal, this would be negative 3 divided by 2 would be negative 1.5 x plus 4, and then you could plug in for that. So if I was going to plug in my typical points there, I don't have a ton of room here, but x, go negative 1, 0, and 1. My equation, y is equal to negative 1.5 x plus, that's not plus 4, it's plus 2. Sorry, I'm going too quick here. So that would be plus 2, and then my x and my y. So that would be negative 1.5 times negative 1 plus 2, so that would be positive 1.5 plus 2 would be 3.5, so negative 1, 3.5. When you plug in the 0, that's always the nice one because you don't have to think too hard, so that would be 0, 2. And then the last one there, negative 1.5 times 1 plus 2 would be negative 1.5 plus 2 would be 0.5. So 1, 0.5. Okay, hopefully I did those right when I did them so quickly. Okay, what we got next here? So graph the equation. Okay, so with these ones, you're probably thinking, ooh, this is kind of weird because we've got y is equal to negative 2 and no x's in there that we can plug in for. So basically how this works is this is going to be a horizontal line, so anytime it's y is equal to any number, it's going to be a horizontal line, which is going this way, through whatever that number is. So through the number. Okay, so when I do this here, when I go to set up my equation, I got y is equal to negative 2, come up with my ordered pairs here, and my x, I can do the same thing where I plug in, a negative 1, 0, and 1, but the problem's going to be here is there's nowhere to actually plug in that x. So what you do is just every single time, your y value is going to end up being negative 2. So no matter what, when you plug in here, you could have any number for your x, and your y is always going to end up being negative 2. So I could plug in, a million, and then my y is still going to be negative 2. Okay, now when I go to graph this, you're going to see this horizontal part. So basically what it's going to look like here, it'd be negative 1, negative 2, so left 1, down 2, 0, negative 2, so over 0, down 2, and then 1, negative 2, so right 1, down 2, and no matter what points I pick there, since my y is always negative 2, basically it's going to be kind of consistent going across there, and it's going to be a horizontal line going through whatever that number was. So that number was negative 2, so it's a horizontal line going through negative 2. Okay, and it'll always work like that if it's y equals some number. Okay, so whatever that number is would be the horizontal line that goes through that number. So if it was like y is equal to 5, it would be a horizontal line through 5. Okay? Now something similar happens when it's x is equal to a number. So like here now we've got x is equal to negative 2. So instead of being a vertical line, or instead of being a horizontal line, this is actually going to be a vertical line. So anytime it's x is equal to a number, so no y's at all, just x is equal to a number, it's going to be a vertical line through that number, whatever that number is. Okay, so in this case, if we were writing it out, all of our x values are going to end up being -2. So when we write this out here, every time we do an x, it always has to be -2. So you don't get to pick your x's in this case. What you get to pick are actually your y values. So here, there's not really anything to plug in there, but what you can do is you can pick out your y values. So you got your x and your y. So here, every single time, the x is going to be -2. Just kind of like it was before, except for the y's were -2 before, and you get to pick out whatever you want for your y's. So we could go -1, 0, and 1. Okay, so kind of see how that works. So this time our x's stay consistent at -2, and our y's get a change. So it's kind of the opposite of what we had before. Okay, so then now when I go and graph those, this should be a vertical line through -2. So when I graph it, it would be -2, -1, so left 2, down 1, -2, 0, so left 2, up 0, which would be right on the line, and then -2, 1 would be left 2, up 1. So then if we draw a line through those ones, it'll end up being a vertical line, so an up and down line. Write that there, through whatever that number is. So a vertical line through -2. Okay, and then our last one here, it says, suppose Old Faithful has an eruption that lasts 1.4 minutes, about how long until the next eruption? And we are supposed to use the graph and the equation on page 253. So if you look at that graph there on 253, it's talking about Old Faithful, which is a geyser, and it says the equation y is equal to 14x plus 27 can be used to predict its eruptions, where y is the time until the next eruption, so y is our time, and our x is the length of the eruption. So length in minutes. Okay, and then it says, and it gives some information here, but we're actually going to use this information. Okay, so it says for R1, suppose Old Faithful has an eruption that lasts 1.4 minutes, how long until the next eruption? Okay, so we know our length in minutes here is going to be 1.4, and we're supposed to figure out the time y until our next eruption. So what we can do here is this is basically our x value. We can take that and plug it in. So 1.4 can plug in for our x, solve that out, and whatever we get is going to be what our y is. So we'd have 14, and then instead of the x, I'm going to put 1.4, because that's what I'm plugging in, plus 27. So then I would just use my calculator. I don't have my calculator on me, but I'd take 14 times 1.4, get whatever you get, and then add 27 to that, and it should end up being 46.6, and then our label would be minutes. Okay? Alright, so that is it for notes. So your book page assignment is page 254, 14 to 40 even.